Hello everyone, this is Nikhil and welcome back to our channel Nikhil's Learning World. This is our Kotlin programming series and this is our 19th tutorial. Okay, so in the previous episode we learned about the recursion and how a function can call itself to solve a problem. Alright, so but today we are going to one step deeper into the something much more powerful and practical. Tail recursion in Kotlin. Now, here is the problem. What if I tell you that normal recursion can actually crash your program, right? Okay, so if your recursion goes too deep, your application can throw an stack overflow error. So that's exactly where tail recursion comes in. Okay, so let's take an example, simple example like an factorial. Okay, so function factorial, uh, it looks simple, right? For example, function factorial, and but behind the scenes, every function call is stored in memory. Okay, so in something called the call stack. Okay, so if you call something like factorial 1 lakh, okay, your program will get crash. Okay, so how we do can fix this? That's where tail recursion comes in. Okay, you got the point. Due to the normal recursion, your program will get crashed. Okay, so you can avoid that crash by using the tail recursion. So very interesting, this concept we have to learn in Kotlin. Some function in tail recursion, when the recursion call is the last operation in the function. No extra calculation, no depending work or no independent work, just a write return or just a direct return. So let's convert a factorial into the tail recursion version. It's very simple, you will see, but before that, so why need the tail recursion? It's like normal uses stack memory, you can cause the overflow errors. Okay, so that's the reason we have to use this tail recursion, and tail recursion optimized by the Kotlin and convert into the loop iteratively. Usage constant memory. That's about the tail recursion. Okay, so just syntax you can see here in Kotlin provides a keyword tail rec. That is a keyword we have to use to define the tail recursion. So this function name, return type, add whatever the logic you have to write there. So tailrec tells the compiler optimize this recursion into the iteration. Got the point? So normal recursion versus tail recursion. So normal recursion factorial function factorial is, you can see here, this is the factorial function. So problem is what? So multiplication happens after the recursion call, not tail recursive. These are the problems. You got the point? So what happened in the tail recursion? The tail recursion receive recursion calls it the last step. Okay, that's it. Result store in the accumulator. You can see here tail recursion function factorial integer, it will be written in integer. If the number equal to 0, it can accumulate, but else in the part factorial will be continued here. So let's dive into tail recursion, how internally it works. So Kotlin convert that factorial function number -1 into number into accumulate. So into the something like a loop, like you can see here, while n not number equal to 0, accumulate equal to number into accumulate number minus minus. So no stack growth and no risk of crash. You got the point? So internally it works in this way. And the key rules are very important. The tail recursion work only if the recursion call it the last statement, no calculation after it, and no additional operations on it. That's the key point. And next is, for example, you can see here sum of number with the normal and tail recursion. In the normal recursion, you can see function it will return an integer. If the number is not equal to 0, that is in the else part, number plus sum minus number minus 1. Okay, but in the recursion function, you can see it will accumulate until the number minus 1 accumulate plus 1 plus that number. That is an example here. So what the advantages of tail recursion? So no stack overflow, it's a faster execution, memory efficiency, clear for the larger type of inputs. That's the advantages. So when we can use this type of recursion functions. So when the large type of inputs we have to calculate at that time we need to in the deep recursion. Okay, so factorial type, some loops. Okay, that type of programs that the calculations, and then we can use this type of tail recursion. Okay, so performance also great as compared to the normal recursion. Okay, so the limitations as like not all the recursion can be converted. Okay, okay, into the tail recursion must follow the strict rule, sometimes the less readable due to the accumulator. So that's all part about the tail recursion. Hope you understand. Please do practices on this tail recursion, so we will get a clear and more idea on that. If you have any queries or any suggestions, you can comment me, and please like this video, and please subscribe if you're not yet subscribed, and please click on the bell notification and you will get upcoming session notifications on your device. In the next session we will see higher order function and inline function in Kotlin. That is a very important part we will see. So this is Nikhil signing off. Thank you.